and start it. Yeah, so we're going to talk about GitOps, continuous delivery, and declarative infrastructure today. Something we've kind of come to learn and love. If you guys don't know me, I'm around here in Des Moines. I'm Luke Amdor. I'm rubbish on just about everything. I've been a programmer for a really, really long time. And I joined a startup called Bano about 6-7 years ago. And I developed software for them, and then I kind of grew into this role of being a lead of the infrastructure team, where I don't really do software for end users. The way we see infrastructure, at least in our business unit, is we see it as we have operations and support and developers, and they're actually our clients. They're our customers. So we kind of develop a lot of tools for them. We develop a platform for them. But one of the things that we've happened to us is when we started, we were 6 employees, something like that. Then we grew to 20. Then we got acquired, and then we were up to I think our business unit is now 150 developers, or 150 people, about 75, 80 developers. Our company was acquired by Jack Henry Associates, who's this big banking technology services company. So what we've come to learn is, more people, more teams, more services, more problems, it kind of seems like. And so we kind of holistically grew up this system. So a lot of what I'm going to present on today is things that we built up over time. And I don't think you really can easily buy an off-the-shelf solution to a lot of this. All of these come down to principles that you can do. But a lot of the things that we do, I hope you at least can figure out how I can apply this to my day-to-day job. So, all right, so to start off with, what is declarative infrastructure? Anybody know what declarative infrastructure is? Good. If you know that already, then you're probably in the wrong room. But what declarative infrastructure is the opposite of declarative is imperative. Duh, right? But what imperative means is, when we say imperative, in a programming context, we mean do this, do that, if this, then that, if this, then that, things like that, right? And what declarative moves towards is, instead of actually trying to say, here's a set of instructions for you to do, you say instead, okay, here's what I want the world to look like, make it happen, right? We gloss over the details. I don't really care about how you install this package, or if it's not installed already, or how you uninstall things or like that. I'm going to just gloss over the details. I don't really care about it, right? And that allows us, as we kind of build up these little things of understanding, this is just going to do this is just going to do that, allows us to build up these abstractions over all of it, right? Instead of saying, okay, I need to get a machine, I need to install Nginx on it, I need what package of Nginx, I could just say, okay, I need an Nginx machine, okay, abstract up more, I need 38 Nginx machines or something like that, right? So what we try to get to is this point of, hey, just make it so, make it happen. Not this, bash, right? And there's some things systems where you kind of think you might be doing it declarative. I don't really think Chef is declarative. User loop, action create, right? Because I can still do things like this. I can say, hey, create me, then delete me. It's still declared, it's still imperative. You're not really modeling things out. There's sequential steps with implicit dependencies, right? And what declarative is trying to get to, and this is kind of, how many know what the OODA loop is? I push this on a lot of presentations, right? Because this really kind of means a lot. OODA is about observe, orient, decide, and act. So how the tools use declarative infrastructure and build this up is they observe the world around them, they orient themselves for what do you want, they decide what to do, and then they actually make it happen. All right. So kind of tools you can do that do all this. Tools like Terraform. How many of you use Terraform? Yeah. So the HashiCorp gods one day, 3-4 years ago, decided, here's this nice tool, Terraform, right? And it's basically, you list of resources, data sources, whatever, and it interacts with APIs and makes it all happen. It figures out the graphs for you. Doesn't care about ordering. You basically say, okay, I need an AMI, go look it up for me, kind of matching this. Feeds that AMI into, when you wanted to create the AWS instance, hey, give me that Ubuntu ID. So it does all the lookups, builds up this nice little graph out of things, and can do things in parallel. And then it could realize, hey, if you change this AWS instance, like, do I need to recreate it? Do I need to update it? Do I need to do all these different things to you? You don't really worry about that stuff. I'm not really like having to look up what is the arcane EC2 CLI syntax for how to do this. Have you ever had to do that? It's not fun. And the idea behind this is like Terraform is just not about AWS. It has a ton of providers, right? There's not just AWS, and they all can be used together. So it's not about like interacting with just AWS resources. Like for us, we do vSphere stuff, we do Vault stuff. But what they could do is you could say, okay, create me this AMI using or create this instance using AWS provider, and then feed it into the input of something else. Like say you want to use like another DNS provider, right? There are tons and tons of providers. So if I have one thing to say to you today, use Terraform and go to Spencer's talk tomorrow about Terraform. Things that might be declarative infrastructure, maybe CloudFormation. I really don't know CloudFormation. From what I've seen of it, it doesn't really seem like it. I don't know how it deals with removing resources, adding resources. I don't know. Maybe it is. One of the things I least think are declarative are container orchestration systems, right? Like I can say, I have this immutable image, and say, okay, deploy this, how many ever you have. We use Marathon at my work. It's a container orchestration platform for Mesos. Mesos is like the scheduler fancy thing. Where basically you throw it JSON, saying, okay, I have an app ID, I need this much CPU, I need this memory. Okay, here's my container. How to map ports, what ports I'm mapped. And I basically tell it, hey, I need 2 of those instances. And it just figures it out for me. I don't have to tell it where to run it. I don't have to tell it what to do past that. It starts and pulls it. It's great. Where we're moving towards is Kubernetes. It's a little bit high for that. Where it kind of works the same way, but I would say it's even more declarative. Like going back to the point of abstractions, like I have this pod, basically where I can say, a pod is like the smallest unit you can have in Kubernetes, where it's just a bunch of containers running somewhere. I can say, okay, start up the Nginx pod. And then I can build up abstractions on top of that, like now with the deployment. Same type of thing. What I had here for the pod part here is my Met template, and I can say, okay, start up 3 of those, and so on and so on. Even services, which are kind of like like an abstraction on service or service discovery, I can say, okay, make this thing, make a load balancer on whatever cloud provider I'm on. Don't have to worry about even the cloud that I'm on. Start up, point at all the Nginx instances on this port. Even more, going even up and up the chain. And the nice thing about this is there's this nice little command in kubectl to say apply that file. And it figures out, okay, what is up there? How do I patch it? And apply it. It's great. The idea behind this is that Kubernetes is not just like API driven, it's API centric. So you're declaring to the API server, hey, I want you to create this thing for me. And then something else on the other end, in the other end of the OODA loop is figuring out, oh, you want to run a pod or you want a deployment? If I need to do a deployment, I need to create pods. So it creates the pods. Something else looks at that and it's like, oh, you want to run these pods? Where do you want to run them? I'll figure it out for you. That's the idea behind it. So this is even getting to the next step of declarative infrastructure. I can build up and build up and build up the abstractions, and something else handles it all for me. It's crazy. I love it. All right, that's enough of declarative infrastructure. All right, GitOps. GitOps is just taking everything, throwing it in a Git repository. Not quite. This is kind of how we do it. So we throw everything in one fat repository. We call it the environments repository. And what this guy has in it, it's not a mono repo for the whole organization. Like, we don't have all of our code, like our application code in it. I mean, we have tons of other repositories. But the way we look at it is those types of repositories make artifacts, right? Things to, like jars of whatever, Docker images. What we see it as is like that environments repository is where all the deployments happen. Where they're all configured. what version they are at. And I'll kind of get into a little bit how that all happens a little bit more. But it's really what we call the desired state of all the environments. But putting it all in one repository gives us so many advantages. It keeps things dry to a point. I think dry, don't repeat yourself. I think dry is good for most things. But when you get into like configuration a little bit of duplication is really pretty good. It'll freeze you up otherwise. I'll talk about that a little bit more. It allows us to say, okay, what all uses this thing? I can search in one repository, find out, okay, what all is configured to look at this database, right? Otherwise, with GitHub organizations, it's a little bit easier, but it's still semi-open-ended concept. Wide configuration changes. This happens all the time for us. Say we want to change, well, not all the time. Say we want to change all the JVM settings on our apps. We just change it once, make a PR for it, and deploys it all out. This is kind of interesting, and this is kind of an unintended consequence of this. TPS, Toyota Production System, they have this thing called a rope. I can't remember even what the name of it is. But so in Toyota's production line, it's all one long line, right? Car starts there, goes all the way, you build the frame, build on the wheels, everything else, all the way down the one line. I don't know what it's called now, it's add-on. But they have this thing, if anybody realizes there's a defect or they need it to stop, they pull on this cord called the add-on rope, right? And it stops the whole line. So by bottlenecking all of our deployments into one place, we stop people from piling on the overall problem. So if as we're promoting through the environments, realize, okay, this one configuration change that we made right here broke things, nothing else deploys. It's okay. I would say that it's got its, it's helped us a lot from just avoiding the pile-on problem, but it also, developers get kind of annoyed at it too, but it is what it is. Pull requests for configuration changes. How many of you use GitHub or GitLab, something that allows like merge request change, pull request? Doing pull requests for configuration changes is a big deal in my mind, because then we actually have an actual discussion about what are we trying to accomplish with this, what is this actually doing? The whole actual conversation is there, have the context for us. And 2 years later, when I want to figure out like why the hell did we change this? I have that full context right there. We'll link in Slack into it and all this other fun stuff, but it's really paid off a lot there. This is my current life right now. Easier audits. It's so much easier to be able to create a script that just goes to the environments repository, pulls up server listings or versionings of things, and just spit it out, versus trying to keep a spreadsheet up to date. So much easier. It's my current life right now. And so on. It just kind of builds up that way. So anyways, this environments repository. This is all it really is. Local, kind of talk about that. We actually do 3 environments: staging, UAT, and production, shared, and scripts. And that's really all we do there. We use a lot of symbolic links within it. And this is kind of the hardest part for somebody to get used to. It's like under an environment, we'll have like a YAML file or JSON file, and it'll symbolically link relative to something else under shared. For things that don't really change between environments, but you need it all the same. It allows us just to change it one place, and we'll see it as changed in all the other different environments as well. It's just a little trick. But that works for some things, but like most things we want actually environmental overrides. Like what version is this app running? You don't really want to be able to say, push out the same version at some time. So you want to be able to say, okay, staging is going to be at this version for a while, UAT will be at this version, or there's so many different like configuration values that are different in environments too. So we use a tool called JSONit for this. How many of you ever heard of JSONit or know what it is? Hey, I'm surprised. It's a really great tool. It's weird, but it's weird. It's cool. A lot of the tools that we use nowadays all use JSON as input and output. And instead of trying to kind of throw on this programming language like throwing Python on it or Ruby on it and try to read it in, JSON is like It's not really a templating language. It's somewhere in between the world of a real programming language and a templating language. But it treats JSON as a first-class abstraction, or first-class citizen. I mean, it's just got a lot of quirks. It's weird. But if you really kind of squint real hard, I would say it kind of looks like Python. It came out of a Google 20% project. But so like something like this, well, you got a basic app with a name version, and you can have overridable variables, and you can put local variables there, if this, then some string formatting. And this whole blob actually returns you not a hash, a map, a JSON map, whatever, JSON object, that's what I guess it's called, for you. And then you can call it just like, hey, import it, and call it, and then you can override things within it. That's all it really kind of can do. But the imports kind of allow you to have a whole library of functions and call them in and mix them all in. So what we'll do is we'll have, oops, I kind of went ahead of myself. We'll have a basic template like this for an application. So they can override things that they want to be the same on all our environments. And then we'll have an additional set of overrides in another JSON file. And then it kind of has this nice little, the standard is like the standard library of JSON. Hey, merge patch just kind of applies that over the top of it. It works out pretty well. So then like in a repository, in our environments repository for an application, so we have an app called Template Service, which I encourage every organization to do as well. It's just kind of a dummy application that is owned by a team, goes through all the environments, goes through all the environment promotions. We use it as a template for other services to be kind of used as a model, but not necessarily like a strict model. But we use it to test out deployments, to test out different ways of doing things, different monitoring, different metrics. It's really kind of cool. So anyways, going back to this is we'll have an application directory under staging marathon template service. And we'll have that list of overrides. We'll have the JSON file, which is a symlink to a ridiculously long path, a symbolic link. We'll have a version file, which just has a single string in it of what version it is. And then we generate, basically just say JSON it, template service to give actually the JSON file, and it creates a JSON file. Ta-da. We check in the JSON files as well too, the actual generated output, because it's nice in a pull request or any type of commit like that to see, okay, what did I change in the template and what did the actual end result change look like as well too. So we'll check those in so they can be applied. And then at the very bottom of it, we have a make file. That basically, this is some arcane make stuff here. For a JSON file, we have to have JSONet file next to it, version, overrides, some other stuff, and we just say, hey, this is a little shell magic here. So this is the way to say, take that file and then output it to what it should result be. Not shell magic, but make magic. And then we'll have some other task in here, like a validate. And a validate is kind of a really pretty nice thing. We run tests in any language. BATS, you guys know what BATS is? It's like a bash testing framework. It's really simple, really dumb simple, and it doesn't have any dependencies. The one thing that's shied me away from using Ruby or Python or anything from this is dependencies. Bash is dumb. It's great. All right, so, but the thing about JSON is that, like, it's JSON. It's not really that great for schemas. So we have a validate that runs against all JSON to make sure that it actually follows the schema for what it's doing. Like for Marathon app, it stops us from like having mistypes or anything like that, or typos. We can formalize any rules as part of that. Like if we have a new app, we don't want it to merge into deployment for any like images actually made. So we have tests that actually check, hey, does the image exist? We check things like, hey, you have the heap defaulted to something ridiculously high that is lower than, or is higher than your mem limit. And then one of the newer things that we've started doing is we add a team label on everything that we add as metadata. On all apps, on all Kubernetes manifest. primarily is because it allows us to know who owns it. But we also can use a lot of dynamic alerting off of that as well, too. In Kubernetes and Prometheus, you can pull off the labels off of the pods, and then you can use those to basically do routing rules for alerting. It's pretty cool. Anyways, so we enforce that as a rule in our validate steps. Say, hey, you got a team label. Just make sure that that happens. And then it's kind of like a final check before the merge. We run on all PRs. Pretty cool. So another thing that we use too, if you go down the JSON way and you're using Kubernetes, there's a project called KSonnet by the Heptio guys, where instead of having this step where they validate where we're checking schemas, which we still do because we don't use KSonnet for everything, but it takes Kubernetes has an API, has this giant JSON schema, and it's the KSonnet guys figured out like, okay, we can take that JSON file, this JSON schema file, and generate JSON functions out of it. That's crazy, but this is the world that we live in. So you get this giant clunk here. But the nice thing about this is like, I know I'm not going to have a typo here. I know that when I call that with command, or if I mistype this, JSON will complain, not when I try to deploy it later. So we, at the very base, we have that scripts directory. Say, hey, add marathon.sh, and you give it some arguments. We expect devs to run this to create a new application, and they do it without problems. And then they create a PR for it. We might get to the point of automating this a little bit better than just a bunch of shell scripts right there, where you can say, you could create a Jenkins job, for instance, that like feed it in input and it runs it for it. I don't know. We haven't really had that many problems with devs running that script. The nice cool thing about all of this too is, and I kind of talked about this a little bit, is pull request. We use pull request on this, and we basically automate a lot of this. We have Jenkins pull at the commits, look at the changed files, does that make, pushes up results, runs make validate, and then comments on the things that we will change. So we can get a heads up view before it actually gets merged in, like, okay, these files are going to get changed as well. These things will get deployed as well. We have to do a little bit of weird things, not weird, a little bit of logic to figure out if I change this file, what else does it symlink out to? Those all things need to get deployed as well. So the nice thing is with doing all the templating in the environments repository is that you can treat local development as like an actual priority instead of something else. We kind of treat, we had this other tool, I'm not going to get into that, but where we kind of did the local development in whole separate repository, but we've kind of been moving it into as part of the environments repository, so that we want our deployments as we're doing things locally to be the same type of deployment that we would be into any other type of environment. If I'm using Kubernetes, I'm running Minikube locally, I'm using the same generated things that generated my manifest for staging in production, and all those environments for locally as well too, so it allows me to test out changes or anything like that. So I kind of have qualms about whether or not local development's actually good or not, like this. That could be an open space thing. It just turns out like our environment has gotten so large that I can't expect people to run things locally and keep things up to date as well, where they should be able to but develop against like the staging environment. All right. Secrets, how do we keep secrets in a Git repository? We use something called Blackbox from the Stack Exchange guys, or Stack Overflow guys. I guess Stack Exchange is the company name. And what it does is it allows you to have a file, and you can say Blackbox register this file, and it keeps a GPG key ring locally in that environment, or in that repository of what all, like, I don't really want to explain GPG. So in GPG, everybody has their own private key and public key, right? Everybody keeps their private key. And what you do is you add the public keys to this key ring. And you can say Blackbox just kind of manages it all for you. So when it encrypts a file, instead of everybody having a shared key, everybody has their own shared key, so it encrypts it how many ever people are in that key ring. It's pretty cool. It allows us to basically keep the things in there secret that we need to be, and we don't have to like lock down repositories or anything dumb like that. So, all right. So, okay, we're running out of time here. All right. So, how does this all kind of fill in with continuous delivery? So, all these different things that we've kind of built up, well, we've always had a strong importance on continuous delivery in our company. But the way that when we went back and we did all this is like, why do deployment changes happen, right? An application version has changed or configuration has changed, right? So there's two different types of pipelines in our apps. And we use our handy butler, Jenkins, to manage this all for us. So I'm kind of gonna have to go through this real quick. A Jenkins pipeline. How many of you know what Jenkins pipeline is? How many of you are using Jenkins pipeline? How many of you like it? That's what I figured. So Jenkins pipeline, it's better than what the alternative was in the past. We've used Jenkins for a really long time, and I've always been kind of jealous of the Travis guys and the Circle CI guys when they came up with this concept of, at least Travis was the first one I saw this. Travis, you have a travis.yaml file that you just check in to your repository, and the Travis CI would just pull that, look at that, and like, oh, here's how you build it. The Jenkins guys did the same thing, albeit a little bit differently. You have a Jenkins file, and you just check it into your repository. You don't have any external job configuration other than telling Jenkins, here's where my repository is, what all branches I care about, and it just pulls that down, looks at the Jenkins file, and the Jenkins file tells it what to do. It uses Groovy, and I've cursed out Groovy a lot, but it's okay. So just be aware of that. It's basically a set of steps. You could say, on this node, check out a node, check out this commit, and then run this command. It's a set of steps. It's imperative, it's not declarative. I can come back to that. You can write your own steps in Groovy. You pull them in. It has a declarative and a scripted pipeline format. The scripted pipeline format was first, so we kind of started using it. Declarative is kind of a prettier scripted pipeline. It's not truly declarative in my mind, but it's close enough. So what we end up doing is we have two different pipelines. We have an application pipeline with its own Jenkins file, and we have our environments repository with its own Jenkins file. And for an application, basically, okay, pull in this library of steps, and we say we have a repository of shared pipelines for different types of projects. So most of our apps are Scala, so we'll say, hey, build out the Scala repository. Where do I get it from? What Slack channel? And then if it's on the master branch, we say, okay, do a deploy of all of that into the environments. And this is actually pulling in steps from the environments repository. So it allows us to change deployments and change the steps together. It's kind of nice. Then our environment pipeline, we do our make, we gather changes, we apply those changes out, blah, 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 blah. But we wait for successful deployments, we do the same for UAT, doing a lot of Slack notifications on them. One of the nicer things is that it'll actually update the pull request as well when it's promoting through the environments. So you actually can figure out from a code change or an environments change, like where is this in the pipeline? That's pretty nice. Application pipeline, pretty much the same thing. I kind of already went through that. So it builds it, does all that, updates the code PRs, and just deploys it all out, automating all of that. And it's really, the nice thing with the declarative infrastructure part of it is that you're just basically are saying one command, like make it so, make it happen, instead of like, okay, I need to SSH into this machine, run this command. You're just saying apply it. All right, gotta hurry up here. All right, so what's next, at least for us? Kind of go back to this OODA loop. So we're always pushing out changes, but we don't really have a good mechanism for knowing if an environment is drifted away from us that easily. Like we can always apply onto it, apply new changes, which looks at a sliver of it to say, hey, what do I need to change? But overall, I want to be able to say, look at this environment, okay, what all is different from my repository from you? And there's some nice tools for that. Box.com has this thing called kubediff, where it basically runs in the cluster and pulls down the Git repository and reconciles the differences against it. And it can apply them automatically, or you can have it alert and say, yo, something's wrong here. The one thing that I think is kind of a little bit harder to do in a declarative system are canary deployments, because it's like this ephemeral, create this for just a little bit of time and do it. We kind of do it, we run things in or some systems we run in a blue-green deployment, where we'll update the blue version. So we'll run actually 2 sets of apps. They're the same apps, but we'll say update all the blue versions of this app and all the green versions. And it's okay. It's kind of not so declarative there. Automated rollbacks, we don't do this. This is something they actually added recently to Spinnaker. Spinnaker is this nice little kind of off-the-shelf tool that kind of does a lot of this. But it will actually be able to look at metrics and know whether or not it should roll back as well. So I haven't really looked at Spinnaker that much, but I probably should. We all probably should. So yeah, I got it. That's it. Any questions or any? Kind of blew through a lot really there, pretty fast. So, if you got any questions, oh yeah, yeah. Yeah.
Once I explained to our auditors that basically kind of like Puppet or Amazon, that changed the entire nature of that conversation. And it made it a heck of a lot easier for us because we have a policy enforcement tool for something that we otherwise have to build and wait auditing framework for.
Yep. I mean, yeah, we use Terraform, and then what we'll also do out of that, see, kind of going back to the JSON is everywhere as well. The Terraform state files are all JSON as well. So we actually have written JSON it that pulls in all the Terraform state files and pulls out all the IP addresses, all of them for them, and builds up alerting rules for those too, because we run what's called a Prometheus node exporter and everything. It's basically, hey, all these nodes. It's great. So as those things change, those things all kind of stay up to date as well. So, any other questions? All right. If you got any questions, grab me in the hall. I'm more than happy to talk about it. So thanks, guys.